So hello students, let's begin our Master Physics Numericals program. So let's start with units and dimensions. So over the next few days what we will do is we will discuss questions from each chapter. By way of doing these numericals, I think I will be able to teach you the entire concepts given in the chapter. So it would be helpful if you can work out these numericals and then again check where you have gone wrong and then try to rectify your errors. If you rectify them, I am sure you will be able to learn all the concepts which are there in the particular chapter. So let's begin with the first chapter, that is units and measurements, and then let's see what's there for us to learn. So here are the first set of questions that you have. So the accuracy in the measurement of diameter of a hydrogen atom is 1.06 into 10 power minus 10. So they are asking you what is the accuracy in this in this measurement. So what can I say? Accuracy I think is the error in the measurement divided by the actual measurement. Maybe if you want to express it as a percentage, you will multiply it by 100. If you want to express it as a fraction, you will just retain it that way. Now here you are given 1.06 into 10 power minus 10. So remember, whenever any measurement is given, the least error will be the error which is there as per this in the second decimal point. So the error in this would be 0.01 into 10 power minus 10. Now when you divide it by 1.06 into 10 power minus 10, these two get cancelled and I can simplify this as 1 divided by 106. So the accuracy in this particular measurement is equal to 1 divided by 106. So option C is the right answer. Okay. So accuracy is defined as the error divided by the measurement. If it is as a percentage into 100, if it is as a fraction, just this part of it. Okay, now let's look at the next question. The length of a rod is measured as 31.52 centimeters. The graduations on the scales are up to. Graduation on the scale means the kind of the least count of the scale. So here the smallest measurement that you have measured is 0.01, only then you can measure 0.52. So if the smallest measurement is 0.01 cm, the graduations must be up to 0.01 cm. So 0.01 cm is nothing but 0.1 mm. Next one, length is given, the breadth is given, they are asking you L by B. Now these are the absolute errors. Absolute errors are the actual errors made in any measurement. You have errors can be expressed in two ways. You have absolute errors and then you have relative errors. So here this is the absolute error, and whenever you do an operation with multiplication or division of physical quantities, we only work with the relative errors and the relative errors are added. So in this case the relative errors are 0.01 upon 20 into 100 plus, in the other case it is 0.02 upon 10 into 100. So this is going to be the relative error. So I can cancel. So this is 1 by 20, this is 2 by 10. So 2 by 10, 1 by 20, totally it will give you 5 by 20. So this is going to be the error percentage. But the question is, let's see. So the question they are given it as 0.01 meter or 0.15 meter or 0.005 meter and so on. So what we need to do is this 5 by 20, we need to convert it into a absolute error. So it will be 5 by 20 into 2, so that will give you 0.005 meters. So option D is the right answer. Okay. Look, I am not doing them accurately. I am not doing them accurately because the errors in each case is different. So if I understand what the number is, I am fine with it. So I got the relative error, converted the relative error to absolute error. The radius of a sphere is measured as 10 plus or minus 0.02%. So if this is the relative error now, so they are asking you the error in the measurement of the volume. So whenever you measure volume of a sphere will be 4 by 3 pi r cubed. So because r is going to be multiplied 3 times, so the error will be 6% or rather 0.02 into 3, so that is 0.06, but they are asking you for the absolute error. So the absolute error will be 4 by 3 pi r cubed into 0.06. Because it is percent, I am going to divide it by 100. So when I work this out, r cubed is 1000. So I can remove this, I can remove this and remove this. So I will get 4 by 3 into 3.14 into 0.6. Assume these two are similar. 4 into 6 is 2.4. So the answer should be 2.4. So this is not 2.4, this is not 2.4, this is looking like 2.4. So option C is the answer, this is not the answer. Okay. So I hope you are able to understand. If the unit of length is doubled and that of mass and time is halved, the unit of energy will be. See, this question can be assumed in two ways. Suppose the unit of length is doubled means right now you are measuring 1 meter. Suppose you have measured 2 meters. Okay. So that means what? Whatever you have measured, suppose you have measured L meters, now you treat it like 2L meters. So that is the meaning the unit is doubled. So here they are asking you for the unit of energy. Energy is mL squared T power minus 2. So mass and time is halved. If mass and time is halved means it will become 1 by 2 of the existing mass. Similarly, the unit of energy, time is also halved. So time is also halved means it will become 1 by 2 of L's, this is minus 2 power minus 2. L squared just now I explained to you, the unit is doubled means it will become 2 times L. So 2 times square. So this will give me half into 2 into 2 into 2 into 2. So the 2's get cancelled, 2 into 2 into 2 is 8 times. So the answer will be 8 times. Okay. Given m is the mass suspended from a spring of force constant K, the dimensional formula of m by K power half is same as that of. So let's see. So they have told me that there is a spring of spring constant K. So can I say that F is equal to K times X? So if X is equal to K times X, I have m L T power minus 2 is equal to K times L. So this L gets cancelled. So from here they have asked me for m by K. So m by K is equal to T squared, or to the power half will be equal to T. So it is same as time period. The dimensional formula for the product of two physical quantities P and Q is this much. Okay. So the dimensional formula for the division of those two is m T power minus 2. So obviously L is what was missing there. So it was L in the numerator, L in the denominator. That means P must have a L, Q also must have a L. So force and velocity is okay, but we can do it exactly and then see. So I think P will be equal to mL T power minus 2 and Q will be equal to L alone. So P is force and L is displacement. So that's how you can work it out. The fundamental physical quantities that have the same dimensions in the dimensional formula for torque and angular momentum are same dimensions in the dimensional formula. Torque is equal to R cross F. So that is mL squared T power minus 2. Angular momentum is mvr. So that will become equal to mL squared T power minus 1. So they are asking the fundamental physical quantity that have the same dimensions in these two formulas are. So the same dimensions are for mass and L squared. So mass and length. So option C is the answer. The physical quantity which has the dimensional formula as that of mass energy divided by mass into length. So I just write down energy is mL squared T power minus 2 divided by mass is mass, length is L. So this will get cancelled, this will get cancelled. So it is L T power minus 2. It is same as acceleration. If J is impulse, if J and E represent they have given the J is angular momentum. If J and E represent angular momentum and rotational kinetic energy of a body, J squared by 2E. Angular momentum is what? Angular momentum is R cross P. P is mL T power minus 2. So mL squared T power minus 2 is angular momentum. Kinetic energy is half mv squared. So it will become L squared T power minus 2. So basically there is nothing there. So there is no unit. So moment of a couple, moment of a force, but they are asking you for J squared. J squared means I am going to square this and then I will get ultimately I will get m L squared T power minus 2. So this is not the energy of moment of a couple. This is not, moment of a couple, yes, moment of a couple is same as torque. So it is R cross F. So it will be m L squared T power minus 2. It is not moment of inertia. It is also moment of a force. It is not force. Moment of a force is R cross F. So this is also R cross F. So both option A will be correct and option B will be correct. Okay, so here there is an error, we will have to see. So if mu is equal to A plus B by lambda plus C by lambda squared dimensionally correct, then ABC. So mu has no units, so A will have no units, B will have the units of L, dimensions of L, C will have a dimensions of L squared. So let's see, no dimensions, L squared, option A is correct. The surface tension of a liquid in CGS system is 45 dyne. So what is its value in SI system? So it is 45 dyne per cm. So that is equal to 45 into 10 power minus 5 newtons divided by cm is 10 power minus 2 meters. So that will become equal to 45 into 10 power minus 3. So it will be 0.045 or 45 into 10 power minus 3. So this will be minute is the unit of time, 10 meters per second squared is the unit of acceleration, and 100 kg is the unit of mass, then the new unit of work in joule will be how much? So now work is equal to ml t power ml squared t power minus 2. So that is kg meter squared into second squared. So if the minute is the unit of time, then 10 meters squared is the unit of acceleration and 100 kgs is the unit of mass. So now here we know that the unit of work is, the dimensions of work is ml squared t power minus 2. So mass 100 kgs. So 100 into 10 meters per second is the unit of acceleration. So if 10 meters per second squared is the unit of acceleration, then it gets a little complicated. It gets a little complicated because work is equal to m into a into distance. Okay, but they are changing the unit of time itself. But understand that the dimensions of time are L power t power minus 2. So when it is t power minus 2, 60 into 60 will come. 60 into 60 is 360. So without much thinking, I'll just go for this. So answer has to be 36 into 10 power 6. The magnitude of force is 100 Newton. What will be its value if the units of mass and time are doubled and that of length is halved? So already we discussed if the length is halved, it will become 2 times L. Then again, I'm sorry, 1 by 2 times L. If the units of mass and time are doubled, mass is 2. So this should be squared into L squared. So L squared, they are talking about force. Force is ml t power minus 2. So if mass and time are doubled, so mass and time are doubled means 2 square into half. So that will give you 4 times. So it will become 400. A motor pumps water at the rate of V meter squared per second against a pressure P. The power of the motor in watt. Power of the motor is watt. So we have to just check which of these combinations will give you the dimensions of power. Is the rate of doing work. Work is ml t power minus 2. So the rate of doing work is by t. So it will become m rate of doing work. So ml square t power minus 2 by t. So that will become ml square t power minus 3. So if I look at it, V meters squared per second pressure. Okay, so pressure is ml t power minus 2 ml t power minus 2 by L squared. Then again, water pumps at the rate of V meter squared. So it is into L squared. If I take L squared gets cancelled. So I don't get power. If I get P by V, if I do P by V, it will be P is m L squared t power minus 2 by L square. Yeah, so I think option A should give me the answer. I made an error here. Pressure is ml t power minus 2, that is force by L squared. Then again they are talking about into L squared. So this is 1. So this L squared will get cancelled. V by P won't. This cannot give you the answer. This V by P also cannot give you the answer. P by V also doesn't give you the answer. Yeah, so only option A can give you the answer. The final velocity of a particle falling freely under gravity is given V squared minus U squared equals to Gx. If V is 18, G is this much, X is this much, then N is how much they are asking. So I have to just use the correct units. So if V is 18 kilometers per hour, it is 18 into 5 by 18, so it is 5 meters per second. G is 1000 cm per second squared, so I'll convert it into meter per second squared, so it is 10 meters per second squared. Then again, X is 120 cm, so that is 1.2 meters. So what is U? So 5 square, so 25 minus U squared equals 2 into 10 into 1.2. So 2 into 10 is like this is like 2.424. So u is 1. So u is 1. So u is 1. So c is 1. The equation which is dimensionally correct among the following: v is equal to u plus at squared is correct. S is equal to v is equal to u plus at squared is wrong. V is equal to u plus at. S is equal to ut plus half at squared looks correct. S is equal to ut plus at squared. This also seems to be correct. This is wrong. So any one of B and C could be correct. Both are them are the same. So we can go for either of them. The dimensions of K in the relation V is equal to K AVT, where V is the volume of the liquid passing through any point of time, A is the area cross section, V velocity of the liquid. So they are asking the dimensions of K. So where V is the volume, so it is L cubed is equal to K A. A is what? A is the area of cross section, so L squared. V is the velocity, so L t power minus 1 into t into t. So these two get cancelled. So this and this gets cancelled. So K is dimensionless. So dimensionless means M0, L0, T0. Any formula that you have, the dimensions on the left side must be equal to the dimensions on the right side. If force F, work and velocity are taken as fundamental quantities, then the dimensional formula of time is how much? So let me start with any one place. So let me start with here. Work is ml squared t power minus 2. Force is again ml t power minus 2. So obviously force and work will not have the same units because mass has to be there. So mass cannot be there. So they will have opposite units. So if they want to have opposite units, that is inverse units. So D seems to be working out. So let me apply and then check. So work power m L squared t power minus 2 divided by F is m L t power minus 2 into V power minus 1. So L t power minus 1. So this and this gets cancelled, this goes up and you get time. So option D is the correct one. The accuracy of a clock is 1 part in 10. So I am assuming there's a typo error here, we'll see. The maximum difference between two such clocks operating for, okay, so it is not just 10, the accuracy of a clock is 1 part in 10 part 10 seconds. The maximum difference between two such clocks operating for 10 part 10 seconds is how much? So if it is operating for 10 part 10 seconds, it is 1 part in 10 part 10 seconds. So it is 1 divided by 10 part 10. So that is equal to 10 power minus 10. Okay, there's something wrong here, but anyway, we'll see. So they're asking you what is the maximum difference between two such clocks. So assume one clock is working on, error is on the left side, one clock the error is on the right side. So it will be two paths. Two paths in how much time is the question. So none of the options here have having two parts. So what I will do is I will go for 5 seconds thinking that 10 by 2 is equal to 5. So I will go for this. I don't have much logic. I need to probably relook at the question and then see and rectify the error in the question. So we'll leave this. There is some error in this particular question. The length of a rod is measured as 35.3 cm. Then the graduations on the scale are up to, like I said again, so this is going to determine the graduations on the scale. So it should be 0.1 centimeter or it would be 1 millimeter. So option D, B is the correct answer. Okay, so let's look at 22. 22, L is equal to 2.06 plus or minus 0.02. B is equal to 1.11 plus or minus this much. So L plus B equals how much? Remember, whenever physical quantities are added, the absolute errors are added. So in this case, it is 0.02, 0.03, it should be 0.05. So if I add them, I'll get 3.17. So the answer should be 3.17 plus or minus 0.05. So option A seems to be the right one. The radius of a tube of a sphere is measured, then the percentage error in the volume. So it is 0.2, so 0.2 by 5.2 into 100 will give me the relative error. So that will become equal to 20 divided by 5.2. So 20 divided by 5.2 is approximately 4, little less than 4. So the final answer will be error in the volume. Volume is r cubed, so 4 into 4 into 4, but little less than that. So I'll go for option A. 2.34 is obtained by rounding off the number, which one? So 2.34, if you take this number and round it, it will be 2.35. If you take this number and round it, because this 5 here is odd. When you have 5 here, the way you the way you round it is just drop this. Okay, if it is odd, you just drop the 5. if it was even. So if it was 2.345, okay, so now there are two numbers. See, suppose I have 2.355 and 2.345. Now when you want to round it, this number is preceded by an even number. When it is preceded by an even number, you just drop the 5. When it is preceded by an odd number, you make it 2.36. So if this 2.355 was rounded, it would have been 2.36. So that is not what we have. So that is not going to be the answer. 2.335, again this is going to be an odd number. If this is an odd number, you are just going to, like I said, if it's an even number, you drop it. If it's an odd number, you go to the next one. So this will be 2.34. This will obviously not be the answer. So option C is going to be the right. The number of significant figures. So these zeros are not significant. So the rest of them are significant. So you have 4 significant figures. The radius of a disk is 1.2, its area according to the idea of significant figures. So area is going to be 1.2 squared, that will be 1.44. But here there are 2 significant figures, the answer also should be rounded to 2 significant figures. So it is pi r squared. So pi, there is no error in pi, so it is going to be 3.14 into 1.44. So if I multiply these numbers, I will get the correct answer. But anyway, because it is 1.2, the answer has to be to 1 decimal. So the answer has to be 1 decimal or 2 significant figures. This is not too significant, not too significant, not too significant. This. Don't waste your time trying to multiply these numbers and then say. Always look at options before you work. When energy is expressed in erg and no significant figure and the number of significant figures is 4, if it is expressed in joules, the number of so number of significant figures does not change with units. So whatever unit you use, whichever way you express, the number of significant figures must be the same. So I will go for option 4. If L is the length of a simple pendulum and G is the acceleration due to gravity, then the dimensional formula for L by G power half. So first thing, understand that T is equal to 2 pi root over of L by G. So this L by G must be the unit of time because 2 pi doesn't have, so it should be for the time. So I will go for time. Dimensional formula for the product of two physical quantities is L T square, T power minus, dimensional formula P by Q is T square. Again L is the option, directly you can see. So the P and Q must be L T power minus 2 and L T power minus 2. So L T power minus 2 will be what? Acceleration. So I should, let's just look at acceleration, displacement and force, velocity. Let's look at distance and acceleration. So distance and acceleration will be the correct one. So one is L, the other one is LT squared. The magnitude of energy is 100 joules. What will be the value if its units of mass and time are doubled and that of length is halved? So like we have been discussing these kinds of questions all the time. So the dimension of energy is m L squared T power minus 2. If the units of mass and time are doubled, so that means this will become 2 into 1 by 2 squared and that of length is halved into 1 by 2 squared again. So this will become 2 cubed. So 100 divided by 2 cubed will be 8 point something. So because 8 point something is not there, I might have made a mistake. Let me check. What will be the mass and time are doubled? Mass and time are doubled means instead of m, I am measuring 2m. Time I am measuring 1 by 2 squared. Okay. Length is halved. Length is halved means I am doing 1 by 2 squared. So the answer is correct. The answer should be 100 by 8, but that is not there. I think they would have given D 800 joules is the answer, but that is error there. I hope you understand what is the error there. If the units of mass and velocity are increased by 2 times, then the unit of momentum will be increased. Mass is becoming 2 times, velocity is becoming 2 times. So momentum will become 4 times. So 4 times means it is increasing by 300%. The initial velocity of a particle is given by this. If u is this, g is this, x is this, then velocity is how much? Velocity in meter per second is how much? So there is some error in the question, but anyway we will just look at it. If u is 18 kilometers means this is 5, so this will be 25 is equal to v, we need to find v, we don't know. G is this means it is 10, x is 1.5, so 2 into 10 is 20, 20 into 1.5 is 30, 30 comes this side, so v squared becomes 55. But they are asking you for v, so v should just be square root of 55, but here as a percentage if they are given, then there is an error in this question, that cannot be the right one. Okay, there is some error in the question. the equation which is dimensionally correct among the followings. So V is equal to U plus half AT is dimensionally correct. V is equal to UT plus, this is wrong. S is equal to UT, this is also correct. S is equal to UT plus half AT squared. T, this is wrong. So V is equal to U plus AT. So A is correct, C is correct. So there are two options which are correct. The error in the measurement of length of a simple pendulum is 0.2%, error in time period is this much. What is the maximum possible error in the measurement of L by T squared? So length is 0.2, T squared, T is 4, so T squared will be 8, so 8.2. So the answer is 8.2. Whenever physical quantities are multiplied or divided, errors are added. The least count of a stopwatch is 1 by 5. The time of 20 oscillations of a pendulum is measured to be 25 seconds. The maximum percentage error in this measurement is how much? So I have measured 25 seconds and I could have least count is 1 by 5th of a second. So 1 unit I might have made an error. So 0.2 divided by 25 into 100. So this would give me 4.8. So the answer is 0.8%. The diameter of a wire as measured by a screw gauge is found to be 1.002 cm. So please understand 4 significant figures. Please understand the accuracy is 0.02 millimeters. 1.004 cm and this much. The absolute error in the third reading is how much? So the third reading. So that given you 3 readings. So the average reading will be 1.004. 1.004. So the absolute error is 0.002. So the answer is 0.002 cm. So this is going to be the absolute error. The velocity of light in vacuum is given. This is expressed in standard form up to 3 significant figures. So 3 significant figures. This doesn't have 3 significant figures. This has. This doesn't have. This doesn't have. So option C is the right one. The length, breadth and thickness of a rectangular lamina are given to you. The volume is how much? So the volume should be expressed to minimum number of significant figures. So here it is 2, here it is 2. So answer should be expressed to 2 significant figures. Here it is 3, not correct. Here it is 3, not correct. Here it is 2, sorry, it is 3, not correct. Here it is 2. So the answer has to be option A. Okay, so here the 0 is significant because it is after the decimal. So here 3 significant, here 180 3 significant, here also it is 1 2 3 3 significant. Here only there are 2 significant figures. So in any answer the number of significant figures must be same as the least significant. So 2 there, 2 there, so we will go up to 2 decimals. I mean 2 significant figures. If the ratio of fundamental units in two systems is 1:3, then the ratio of the momentum in the two systems will be momentum. Momentum is product of two quantities, mass and velocity. So at 1:3 and 1:3 will make it 1:9. So the option has to be 1:9. But here we have to be very careful. Momentum is m l t power minus 2. Sorry, t power minus 1. So when you look at this, this is going to become 3 times, this is going to become 3 times, but this will become 1 by 3 times. So the answer is not 1:9, the answer has to be 1:3. So it has to be 1:3. Okay. Then the velocity of a spherical ball thrown through a viscous fluid is given, where V is something, K depends, the coefficient of this, the mass of the ball. Then, so they want to know what are the dimensions of K. So remember, any exponent cannot have any dimensions. So the dimensions of K is basically t power minus 1. So now let's look at this, which of them will give me t power minus 1. So now I need to know what are the dimensions of viscosity itself. So viscosity is equal to, coefficient of viscosity is F into, I can either remember Stokes law. Stokes law says F is equal to 6 pi eta R V. So here I can say m L t power minus 2 is equal to coefficient of eta L t power minus 1. So this L gets cancelled. So the coefficients of viscosity has a dimension m L power minus 1 and t power minus 1. Okay. So now let me see. So first thing is K will what? K will not have any, will have dimensions of t power minus 1. So m should not be there. So first thing is eta and m should be one in numerator, one in denominator. So this could be, this could be, this cannot be. So one of these two. So now let's assume this is the answer and then let's work. So it is L m L power minus 1 T power minus 1 divided by m. So this will get cancelled. Then again these two will get cancelled and I get T power minus 1. So it should be the exact reverse of it. So if it's the exact reverse of it, then it should be m divided by and eta r. Oh sorry, this is k T power minus 1. So here also we are getting it. So this should be the answer. C should be the answer. The length of a pendulum is measured as 1.01 and time for 30 oscillations is measured 1 minute and 3 seconds. That means 63 seconds. The error in length is 0.01 and the error in time is 3 seconds. The percentage error in the measurement of acceleration due to gravity. So first we need to know T is equal to 2 pi root over of L by G. Then we need to work with relative errors. So let's work with that. First find out the relative error. 0.01 by 1.01 into 100. So that is approximately 1%. Then 3 by 30 into 100. 3 by 30 into 100. So that is approximately 3 seconds. Sorry, 10%. 10%. So T is equal to 2 pi root over of L by G. So measurement of gravity. So T squared. So gravity will become equal to or proportional to T squared by L. So that will make it 21%. So 21% option is not there. So let's see what error we are making. Oh, it is 3 seconds and 63. 3 by 63. So this will become 21. So this is approximately 5. So this is 5%. So 5 into 2, 10 plus 1, 11%. 11% is also not there. Okay, but it will be less than 11% because when you calculate it, it will be little less than 5%. So it is 3 by 63 into 100. So 3 will go 21 times. So it is 100 by 21, which is less than 5%. So maybe we will go for this as the answer. If the velocity v, acceleration a and force are taken as fundamental quantities instead of this, what will be the dimensions of Young's modulus? Young's modulus y is equal to stress by strain. Stress is force upon area. That means it is m L T power minus 2 divided by L squared. So that is m L power minus 1 T power minus 2. So now whatever we do, we have to get the same dimensions. So let us say, let us take f a square v power minus 5, f a square v power minus 5. Okay, so let's assume this is our answer and then let's work. So it should be m L T power minus 2 a square means L power 4 divided by v for velocity. Velocity means L power 5 T power minus 5. So this and this gets cancelled, but here there is an L power minus 1, so it can't be this. Okay, but instead what should happen is, maybe instead of v power minus 5, v power 4 would have worked better, or v power 6 would have worked better. So let me try this one. So this is m L T power minus 2 divided by into a square. A square means L power 4. This is L power 4 into T power minus 4. So this and this will get cancelled. So it is m L T power minus 2. So this is also wrong. So v power 5 is cancelling. So it should be v power 6. So maybe one of these options is v power 6. And then that will be the correct answer. So again there is an error in this. Let's check. So this is T power 4. This goes up and becomes T squared. Oh, I made a mistake. A is for acceleration, not area. So let's go back again. So it is m L T power minus 2. Let's assume this is the answer, into acceleration squared. So L squared T power minus 4 divided by v power minus 5. Now L power 5 into T power minus 5. Now that seems to be working. So here it is L power 5. Here it is L squared into L. So that will become L cubed. So L power minus 2. So that won't be the answer. So I have a feeling that this will be the answer. So let me check it out. m L T power minus 2 into a squared L squared t power minus 4 divided by v power minus 4. So, L power minus 4 into t power minus 4. So, these two gets cancelled. So, this is L cubed. So, this one option A will be the correct one. Okay. It took us some time, but some questions yes. If power P, also students, I am doing these questions, I have not worked out these questions, I have not checked the solutions, I am doing it first time as I am working it here. So, it is showing the genuine time that I am taking to do these questions and the genuine approach that I would have done to get an answer. The power P, surface tension and Planck's constant are arranged so that the dimensions of time in the dimensional formula are ascending order. Okay. So, power is work done upon time. So, that is m L square t power minus 2 by t. So, that is t power minus 3. Then again Planck's constant means energy is equal to h into frequency. Energy is m L square t power minus 2 into is equal to h into frequency is 1 by time. So, it is t power minus 1. So, work done must be power must be at the end, and before power you should have Planck's constant, because this is 10 power t power minus 3 and this is t power minus 1. So, let us see where it is. Then again surface tension is force per unit length. So, that will become m L t power minus 2 by L. So, it is t power minus 2. So, power has a unit t power minus 3, Planck's constant has t power minus 1 and surface tension has t power minus 2. So, if I have to arrange these in ascending order means increasing order. So, power should be first, followed by this, followed by this. So, option A should be the right one. The density of a cube can be measured by measuring its mass and length of its sides. The maximum errors are given to you. The maximum error in the measurement of density. Density is mass by volume. So, here the error is 3%. Here the error is 6%. So, 6 plus 3 is 9%. So, the answer has to be option A, 9%. Energy, angular momentum, universal gravitational constant are chosen as fundamental quantities. The dimensions of the gravitational constant in the dimensions of universal gravitational constant in the dimensional formula of Planck's constant h is, okay, let us see first what it is. The energy E, angular momentum and gravitational constant are chosen as okay. So, energy is equal to h into frequency. So, Planck's constant is equal to energy by frequency. So, energy I am having, so I do not want to disturb. So, now I have to understand angular momentum and gravitational constant. Angular momentum is m, it is r cross p. So, L t bar L square t power minus 1, okay, that is angular momentum. Gravitational constant G is equal to F m L t power minus 2 divided by m squared into L squared. So, it is m L cubed t power minus 2 m power minus 1. This is the thing. So, now they are saying that h is equal to e power x into angular momentum L power y into gravitational constant G power z. Now, they are asking you for the dimensions of gravitational G power how much z, they are asking you for the value for z. Okay, so now this is going to be quite a tough one because I need to work out quite a bit for this. So, what do we do? Okay. Usually, I do not want to work out those questions which take a lot of time because you have to do it fast. So, let us see. But I have to work this out because that is my job now. So, let us see. So, what I will do is I will just put the values and then I will check. So, energy is m L t power L square t power minus 2 power x. Length L is angular momentum is m L squared t power minus 1 power y, and gravitational constant here I have worked out m power minus 1 L cubed into t power minus 2 power z. Now, I need to know the dimensions of h is m L squared t power minus 1, okay. So, that we are seeing. So, here clearly you can see that x plus y will become equal to z. So, x plus y will become equal to z. So, here I have L power 2x, here I have 2y plus 2y here I have so 2x plus 2y plus 3z is equal to 2. Now x plus y is equal to z. So if I substitute here, it will become 2 times z. So 5z is equal to 2. So z is equal to 2 by 5. That should be enough to answer the question. Asking me the value for z. Okay, we'll keep this. We will do it later. But we are getting 2 by. I'm getting 2 by 5. Let's see. The length and breadth of a rectangular object is given and have been measured accuracy of 0.1 cm. Relative error and percentage error in the area of the object are how much? So these have to be measured to this much. So 0.1 by 25.2 into 100 will give you, this will give you 4. So 0.4% in the measurement of length. In the measurement of width, it will be 0.1 divided into 100 divided by 16.8. So 16.8, so this is going to be equal to 10 divided by 16.8. So this will be 16 into 6 will be approximately this much. So here it is 0.6%, here it is 0.4%. So the error in the measurement of area will be 1%. So 1%. So let me go for 1%. So that should be the answer. L, R and C and V respectively represent some quantities. The dimensions of L by R, C into V is how much? Okay, so this is a tough one, are same as those of what? Okay, so it is L by R C V. Now students, you all know that there is something called as a Q factor. Q factor is equal to XL or XC divided by R. Okay, so XL is what? Omega L. Omega L by R is equal to Q factor, and Q factor has no units. So if I have L by R, omega has the units of time. Yeah, time, that to omega is angular velocity, angle covered per unit time. So t power minus 1. So from here I can say that L by R has, if omega is t minus 1 and there are no dimensions, L by R has the same dimensions as t. So I'll remove L by R and have a dimension t. So t divided by CV. Now I also know that Q is equal to, or Q by V is equal to C, or Q is equal to CV. So from here, if I put CV is equal to Q, then I'll get T by Q. So that is nothing but 1 by current. So this is the correct answer.